So ladies and gentlemen, Mistringer is here, and today I'm going to talk about what I'm going to do, or what I'm making is that this basically is a burner, and this is the half part, and this is the second part. This basically in the middle here is the oil gun, which basically takes the fuel through this port and air through this port, and it basically atomizes and breaks up the fuel into very fine droplets that it shoots into this chamber right here in the middle. And it has a, as you can see there, a ignition plug, and which is this, and the other one is a propane input that is basically there to have a pilot flame. Through here the oil gun connects, which sprays the oil into this propane flame, and then it basically ignites, and when that is done, propane is cut, ignition is cut as well, and then we only have the air, which is provided through the here and here with the blower. With here we have a compressor that feeds the air through this needle valve, which is this, and this is basically an automation with a stepper motor and has a limit switch as well for homing. This is like a carriage that when the stepper motor adjusts the needle valve, which is basically there to regulate the air, so basically it controls how much air is put in, and basically this is there to home, so that we know where we start from basically every time when we launch the whole thing. And basically we allow the air from the compressor with 2-bar gauge pressure into the oil gun, which atomizes the fuel. And the fuel pump is not here, but it is basically the whole operation is controlled by this. I have drawn a little paper here that basically we have the fuel pump, the blower, the atomization air, and the gas. The gas is there to ignite. This is the pilot gas, and we all feed that into the MCU, which is the microcontroller unit, or MPU, microprocessor unit, which is the STM32. This is a Nucleo board, the F4476 whatever RE. And basically he controls everything. He controls the stepper, he controls the chopper, which is basically this board here, which is enabling the pump, which is this output. This socket connects to the pump, and basically the pump is fed from 12 volts, separate power supply, but the STM allows the power supply's power to go into the pump and into the blower. And basically with the capability to allow this, it is called a PWM control, which basically you can set the percentage of power that the blower and the pump runs on. And also you can control the step, which is the position of the needle valve. And all that is basically done, except the gas for now, because that is not automated just yet. I will have to do that manually. So the fuel, the blower, and the atomization air is fully automated. I mean, not automated in the sense that it has its own sequence, but it can be basically driven from a laptop manually. So it is half automated, and basically then I feed the signal, or basically the MCU controls them. So this is supposed to be in the reverse, but the fuel, these are the data that I want to set. When I put each data in to the MCU outputs some signal, and basically that will control the burner. And this is the main thing. I have been working on this, and hopefully I will be able to run and assemble the burner today. I mean, I will not run it today, but I will be able to test it about 1 to 2 days from now, which is probably on Wednesday or Tuesday, but probably on Wednesday. And yeah, so everything is done with the STM, which is basically being able to control. So yeah, I was doing this, as well as like I have left out one thing, which is the ignition, which is heat basically, and that is run from a 5 kilovolt transformer that basically the relay is controlled by the STM32 that I can also control via inputs and through the laptop, and that is basically enabling the ignition plug. So yeah, this was it. What I was also tinkering around is this, which is basically this planetary gearbox. This is just a kind of fun side project, side quest that I do, and I am doing this just for winding down at the end of the day. So yeah, I think this was it. Thank you for watching. Do the hard work, especially when you don't feel like it. Mwah.